In this video, we're going to be working out two example problems to help you understand how to calculate the root mean square velocity and also a variation of the problem where we're solving for temperature as well. We're going to be focusing on these two equations, the average kinetic energy equaling 1/2 mass times that root mean square velocity squared, and 3/2 times kb Boltzmann's constant times temperature. In some cases, you're going to have to include this n, which is going to be the number of molecules if you are solving for something with multiple molecules. This one, we are not going to be focusing on that type of problem, so we're going to go ahead and ignore that one for today. So we have two formulas which are equivalent to each other, so we can go ahead and say that 1/2 v squared is going to be equivalent to 3/2 k times t. Now, if we do a bit of rearranging to solve for v squared, we can go ahead and multiply both sides by 2, which is going to get rid of our 1/2, and then the 2 in the denominator over here. And then we can go ahead and divide both sides by m, which cancels it on the left side, and then finish off by square rooting each one of the sides. And then we have our solution isolated. So we have our root mean square velocity equal to the square root of 3 times kb times t all over m. So in this case, we have most of which we need. We have to do a bit of converting. We have this constant, Boltzmann's constant of 1.38 times 10 to the negative 23rd. And then we have our temperature, but we just need to do a little bit of converting. We're going to take our 150 degrees Celsius, add 273 to it, and then we have 423 Kelvin for our temperature. So that's in the standard unit. And then lastly, we need to solve for the mass over here. Now, we don't have much to work with, so we have to do a bit of converting off to the side. So if you take a look at the periodic table, we know helium has 4 grams per 1 mole. So we can do two different conversions to get it into the standard units we're looking for. First of all, we're going to go ahead and change that grams, those grams, into kilograms, which is basically dividing by 1,000. So now our grams is in the unit of kilograms. We have 0.004 kilograms per 1 mole. We're not interested in analyzing an entire mole, so we're going to do one more conversion, and we got 1 mole equal to 6.02 times 10 to the 23rd molecules. So we are basically just dividing these two numbers, and we're going to get a very small number, which comes out to 6.64 times 10 to the negative 27th kilograms per molecule. All right, now we have everything that we need. We can go ahead and slide that into the denominator. Now, for me personally, I like to put this into smaller steps into the calculator. Honestly, it doesn't matter. You could plug it in as one giant step and then plug everything in. I tend to put in the denominator first, or excuse me, the numerator. And I'll take 3 times 1.38 times 10 to the negative 23rd times 423, hit enter, divide it by 6.64 times 10 to the negative 27th, and then square root that answer solution in my calculator. And then I would eventually get a final answer of about 1,624 meters per second as my final solution. Now, as I said before, there are plenty of ways you can plug into the calculator. I tend to put it into smaller chunks so I don't have to wrap as many things in parentheses, but whatever is your preference works too. So we got 1,624 meters per second as our root mean square velocity for the first one. So let's go ahead and clear the screen and then take a look at our second example. For our second one, we have the root mean square velocity of 1,293. And then we are going to find the temperature in degrees Celsius. So for this one, we are still going to use both formulas. We still have 1/2 mv squared equal to 3/2 kT. As we did last time, we can go ahead and do a bit of canceling, multiply both sides by 2, except this time we want to scoot other things around. We want to divide both sides by 3, and then we want to divide both sides by Boltzmann's constant. So slide our KB over here in the denominator. All right, now we are ready to go. We want our mass, and we did do the conversions for the mass already in the previous problem. So I'm going to go ahead and steal that number of 6.64 times 10 to the negative 27th. And remember, that was the kilograms per molecule. And then multiplied by that root mean square velocity, 1293, and square that. And then on the bottom, we have 3 as our coefficient in front of Boltzmann's constant, which is 1.38 times 10 to the negative 23rd. Okay, so I'm going to go ahead and plug that into my calculator, and then I end up getting 268.14 Kelvin. Okay, now if you want to convert that into degrees Celsius, you could go ahead and subtract 273 from that number, the opposite of what we did earlier, to get it into the standard units of Kelvin. And now we get our final answer, and that comes out to negative 4.86 degrees Celsius. And then that takes us to our final solution of what they asked us for, since they did ask for it in the units of degrees Celsius. So when doing these problems, lots of fairly big and small numbers that you're dealing with here. You're going to have to do a little bit of converting and a bit of rearranging, and then from there you can go ahead and find the root mean square velocity and other variables such as the temperature. So hopefully that was helpful to you. Thank you for watching and listening.